Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Today our group from group 1 would like to present about uniform flow and steady flow for fluid mechanics DCC 30122. Our lecturer name is Wan Ahmad Faizal bin Wan Abdullah. Our group members Amri bin Suhaimi, Ketigan son of Malingam, Muhammad Anis Syazwan bin Adib, me, Wan Muhammad Adib bin Wan Mastuk Syarif, Nur Mazatul Syafiqah binti Mukhtar, Nur Syahira binti Muhammad Daud, Nik Muhammad Ashraf Zafran bin Ishamuddin, Aina Najah binti Hasmi, and Muhammad Hafiz bin Nazri. There are many use of uniform flow and steady flow in fluid mechanics. Now I would like to pass to Wan Muhammad Adib bin Wan Mastuk Syarif for introduction of uniform flow and steady flow. Thank you.
Okay, first of all, my name is Muhammad Hadi bin Mastuk Syarif. My metric number is 01DKA21F1041. Now I will to continue about introduction. First, uniform flow. Uniform flow is defined as that type of flow in which the velocity of flow of a fluid at any instant does not change with respect to space. In other words, it is a flow in which the velocity of flow remains constant throughout the flow field at the given time. Second is steady flow. Steady flow is that type of flow in which fluid parameters, for example velocity, pressure, and density, at any point in the flow field do not change with time. Now I would like to give my friend to continue about this presentation.
Alright, thank you Nick for your explanation about the definition of uniform flow. So I'm Namazatul Syafiqah binti Mukhtar and my metric number is 01DKF1042. So I will to explain for you guys about the uniform flow means. Uniform flow means fluid flowing into the different parts to the fracture surface with equal flow velocity per unit area. The literature put forth an opinion that uniform flow type curve applicable to those will connected or natural vertical ratio. So masuk kat sini aliran uniform flow tu yang masuk aliran seragam masuk medali mengikut kebahagiaan yang berbeza, tetapi dengan halaju aliran yang sama. Walaupun laluan yang berbeza, tapi dia mempunyai masa ataupun halaju dia sama dengan lain walaupun aliran dia berlainan.
Uniform flow. Definition. Flow of a fluid in which its particle move along its line of flow with constant speed and in which the cross-section of its stream tube remains unchanged to compare steady flow. So aliran bendali ni di mana setiap zarah dia bergerak sepanjang garisan alirannya dengan kelajuan yang malar dan di mana keratan rentas setiap tub aliran kekal tidak berubah berbandingkan dengan aliran tetap iaitu steady flow.
My name is Amri bin Suhaimi. Now I will continue to the steady flow. The flow of a fluid is steady if its velocity, pressure, and all the numerical values relating to its substance, for example density and viscosity, are independent of time at every point in the flow field. A steady flow is in principle only possible in a condition of equilibrium, steady state. Now I will pass to my friend.
Okay, thank you to my friend. Now we continue the presentation. First of all, my name is Muhammad Hafiz bin Nazri. My message number is 01 DKA21F1046. So, now we continue with steady flow. What is steady flow? Steady flow is a flow in which the velocity of the flow at a particular fixed point do not change with time. It's also called stationary flow.
Hello, my name is Aina Najah binti Hasmi, metric number 1045. I will continue the present about example for steady flow and unsteady flow. Steady flow. It is the flow in which condition of flow remains constant with reference to time at a particular section, but the condition may be different at different section. Example, a constant discharge through a pipe. The calculation for steady flow is dV over dt equal to 0, which means V is constant. Unsteady flow. It is the flow in which condition of flow change with reference to time at a particular section. Example, a variable discharge through a pipe. The calculation for unsteady flow is dV per dt not equal to 0. So, V is variable.
Hi, my name is Nushaira binti Muhammad Daud. My metric number is 1043. I want to present about example of uniform flow and non-uniform flow. First, let's see the uniform flow. The flow in which velocity at a given time does not change with respect to space is called as uniform flow. For the example is constant discharge to a constant diameter of pipe. Second, let's see for non-uniform flow, the flow in which velocity at a given change with respect to space is called a non-uniform flow. For the example is content discharge to variable diameter of pipe.
Three. Thank you, Shira, for your example explanation. So next, I will conclude the uniform flow and steady flow. In conclusion, difference between the values of these two flow rates is because the theoretical flow rate depends on the slope of the channel bed and also on the other factor like Manning roughness coefficient, but the measure flow rate depends only on the area and velocity of the fluid through that area. Applying the same flow rate at different slope has shown that the change in the slope of bed change the theoretical flow rate value as it depends on the depth of the flow. And that's all from our group for this uniform and steady flow presentation. Thank you.
Assalamualaikum and hi everyone. We are from group 2 who would like to present about flow visualization of fluid mechanics DCC 30122, and we are from DKA 3B. Our lecturer for this subject is Tuan Wan Ahmad Faizal. Okay, next I will introduce my group members. First, Oganadin, son of Magasuarin, Muhammad Ashraf bin Muhammad Yusuf, Sabri bin Muhammad Fuad, and me, Muhammad Azlami bin Abdul Halim, Adam Zahiri bin Sabri, Nur Dana Umairah binti Azni, Hanif Syazwan bin Darussalam, and Muhammad Amirul Aiman bin Ishaq. Okay, next I will pass to Dana to continue the presentation to explain about the introduction of flow visualization. Thank you.
My name is Nurdana Umairah binti Azmi and I will talk about introduction. First, flow visualization is used to make the flow patterns visible. And second, visualization of fluid flow is one of the most important experiments in fluid mechanics. And next, many methods have been developed for making flow visible. That's all from me and I will pass to Sabri.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sabri bin Muhammad. My metric number is 01DKA21F1058. So I will present method for making flow visible. First is dye injection method. Dye injection method is employed in a water tunnel or water channel. The method is to introduce dye by injection tube needle to the location of interest in the flow field. So we have two example picture at here. So the first picture is from the front and the second picture is from the side. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad Yusuf. My metric number is 01DKA21F1057. Next is oil filler method. First, apply to some viscous fluid mixed with solid powder, whose color is easily visualized by eye on the test model. Second, the pattern revealed by the oil film provides the information of flow near the model surface. The example that we can see flow visualization using oil film method.
Okay, thank you to my friends. Next, I will continue about hydrogen bubbles technique. The technique consists of using the bubbles produced by the electrolysis of water as a flow visualization tool. Using a fine wire mounted perpendicular to a wall as the cathode or negative electrode in a DC circuit and another material, such as brass as the anode or positive electrode. The production of hydrogen occurs on the wire when it is excited by an electric pulse. If the fine wire were made the anode, oxygen bubbles will be produced. The wire is designated as the cathode because the hydrogen bubbles generate data approximately half as large as oxygen bubbles produced there, and serve better as tracers of the flow due to their smaller buoyancy force. Okay, Okay, next, this is example of flow visualization using hydrogen bubbles technique. Okay, next, I will pass to my friends to continue about the flow visualization process.
Thank you to Amirul Aiman. My name is Yoganathan, son of Magesoran. My metric number 01DK821F1049. Next, I am continuing with the flow visualization process. Scientific visualization with computer-generated images can be generally conceived as a three-stage pipeline process. We will use an extended version of this process model here and discuss its application to flow data visualization. The first process of data flow visualization is data generation. Production of numerical data by measurement or numerical simulations. Flow data can be based on flow measurements or can be derived from analysis of images obtained with the experimental visualization techniques as described in section 2. The next step is data enrichment and enhancement. Modification or selection of the data to reduce the amount of or improve the information content of the data. Examples are domain transformations, sectioning, thinning, interpolation, sampling, and noise filtering. The third process is visualization mapping. Translation of the physical data to suitable visual primitives and attributes. This is the central part of the process. The conceptual mapping involves the design of the visualization to determine what we want to see and how to visualize it. Abstract physical quantities are cast into a visual domains of shapes, light, color, and other optical properties. That's all from me.
Okay, thank you, Yoga. So now I will continue the presentation. Name is Hanif Shazamir Salam. Next is rendering. Generally, the rendering process has 4 stages: viewing, transformation, visible surface determination, lighting calculation, and scan conversion. Often, a visualization will consist of a combination of several types of primitives, and therefore it is profitable if a visualization system permits the use of many different primitives in a single image. And lastly, it display. Particle motion can be very effectively visualized using animation sequences. Animation can be either be produced in real time or simply by playback of a series of pre-computed image frame. In real-time animation, rendering of each frame is done during display. So that's all from me. So now I will pass to Adam Zuhairi. Thank you.
Okay, my name is Adam Zuhairi bin Sabri. Okay, next by conclusion. Okay, flow visualization will not be restricted to the technique for giving an intuitively appealing general impression of flow patterns, but will increasingly focus on more specific physical flow phenomena such as turbulence, circulation, air reattachment, shock waves, or free liquid surface. Also, purely visual analysis of flow patterns will be increasingly complemented by algorithmic technique to extract meaningful patterns and structures that can be visualized separately. Okay, that's all from us. Thank you.
Good morning everyone, we are from Group 3. Today our group would like to present about compressible and incompressible flow. We hope you enjoy our presentation. Before that, let me introduce our group members. Our group consists of 8 people. First, of course, me, Nurul Aibatisha binti Zaharun. Next is Ifan Nasira, Aira Rosariha, Ahmad Syami, Nurul Alia. We also have Muhammad Zari Hamka, Nur Nazira, and lastly we have Muhammad Khairul Ashraf. So, without wasting any time, let's move on to our main topic. So, I will talk about hydrodynamics. What is hydrodynamics? It is a branch of physics that deals with the motion of fluid and the force acting on solid body immersed in fluid and in motion relative to them. It's part of a larger field called fluid mechanics that we study how energy and force interact with fluid, including gas and liquids. The example is the behavior of waves in the ocean. That's all from me. I will pass to Ifa.
Next, we want to talk about types of fluid. First, real fluid. Second, ideal fluid.
Third, incompressible fluid. And fourth, compressible fluid. Thank you.
Next is definition compressible and incompressible. Compressible. The property of volume change is called compressible, and a fluid whose volume change is called compressible fluid. Incompressible.
An incompressible fluid is a fluid which is not compressed or expanded and its volume is always constant. In reality, a rigorous incompressible fluid does not exist.
Next is difference between compressible fluid and incompressible fluid. Compressible fluid. Compressible fluid is matter that can be compressed with the application of an external pressure. Next, its density can be changed with the application of a pressure on the fluid. Lastly, volume can be reduced with the application of a pressure on the fluid.
Incompressible fluid. Incompressible fluid is matter that cannot be compressed with the application of an external pressure. The density cannot be changed with the application of a pressure on the fluid. And lastly, volume cannot be reduced with the application of a pressure on the fluid.
Thank you to my friend. I will continue the presentation. Example of a compressible fluid and incompressible. Compressible fluid. In the fluid, the density of fluid does not remain constant during the process of flow. In other words, the density of the fluid changes from point to point in compressible flow. Incompressible. In the fluid, the density of the following fluid is constant during the process of flow. For example, in compressible fluid, velocity is greater than 100 meter per second. And example for compressible fluid is velocity is greater than 100 meter per second. Thank you.
Okay, next is conclusion. The conclusion is a fluid is a substance that can flow easily. A fluid has no definite shape and it takes the shape of the container which it is occupied. There are very weak attraction force between molecules of the fluid. Gas and liquid phases are considered as fluid mainly due to their ability to flow. Gases are called compressible fluid, whereas liquid are called incompressible fluid. The main difference between compressible and incompressible fluid is that a force applied to a compressible fluid changes the density of a fluid, whereas a force applied to an incompressible fluid does not change the density to a considerable degree. Thank you. That's all from our group. Thank you again. Bye.
Hi everyone, a very good morning to sir and my fellow friends. First of all, I would like to introduce myself. Okay, my name is Nagavishnu, daughter of Sukumaran, and my matrix number is 01DKA21F1070. We are from DKA 3B. Today, my group and I would like to present about 1, 2 and 3 dimension from topic 3, which is hydrodynamics.
Okay, group member. The first one is Mama Afi bin Izwan, 01DKA21F1148. Second, Siti Nur Atikah binti Zainal Abidin. Nama matrik 01DKA21F1141. Third, Ghazi Ghazani bin Azman. Nama matrik 01DKA21F1154. Next, Taufiwa. Nama matrik 01DKA21F1071. Okay, next, Nur Aniza binti Aznan. Nama matrik 01DKA21F1159. Okay, next, Akmal Haika bin Faizal. 01DKA21F1069. Okay, next, Syamil Aizat bin Cik Razali. 01DKA21F1068. Okay, last one is Naga Vaishnavi. 01DKA21F1070. Okay, next content. First one, introduction. Second, one-dimensional flow. Third, two-dimensional flow. Okay, next, three-dimensional flow. Next, quarters. The last one is conclusion.
Okay, there are 3 dimensional in hydrodynamics. Let's see what is 1, 2 and 3 dimensional.
Okay, my name is Muhammad Syamil Azad bin Encik Razali and my registration number is 01DKA21F1068. Okay, I would like to present about introduction. Okay, term 1, 2 or 3 dimensional flow refers to the number of space coordinates required to describe a flow. It appears that any physical flow is generally 3-dimensional, but these are difficult to calculate and call for as much simplification as possible.
Okay, my name is Muhammad Hafiz Muhammad Izwan. Number metric 01DK21F1148. Okay, today I will present about one dimension flow. Okay, the flow is one dimensional if the flow parameter like velocity, pressure, depth, and other than that, this change only in the direction of flow at a given moment and not across the cross section. Okay. Second is the flow may be unstable. In this case, the parameter alter in time but is still not across the cross section. Okay. Next, I will pass to Ghazi.
Hello, my name is Ghazi Ghasani bin Azman. My matrix number is 01DKA21F1154. I want to continue about one dimension flow. For an example of one dimension flow is the flow in a pipe. So this is the picture of pipe, and this is the picture about ideal flow, and this is the picture about real flow.
Assalamualaikum and very good morning. My name is Akmal Kabazal. My matrix number is 01DKA21F1069. Today I will continue the presentation is about two-dimensional flow. Two-dimensional flow can be assumed that the flow parameter differ in this direction in the direction of flow and in one direction in the right angles. In this type of flow, the streamlines are curved lines on one plane and are same on every parallel plane. An example is flowing over a wave for which typical streamlines can be seen in the figure. All flow parameters are purpose of time and two space coordinate, let's say x and y. No variation in the z direction.
Hello, Assalamualaikum. My name is Naraniza binti Aznan. My matrix number 01DKA21F1159. Thank you. I will continue with the next slide presentation. Let us see about two-dimension flow. Two-dimension flow is a type of flow in which the velocity is a function of the time and two space coordinates, say x and y. Mathematically, for two-dimensional flow, u is equal to f1 xy, y is equal f2 of xy, and w is equal to 0. Let us see the example for two-dimension flow. The water flow of a well is a good example for two-dimension flow. Hello, Assalamualaikum. My name is Naraniza binti Aznan. My matrix number 01DKA21F1159.
Hi, my name is Siti Nur Atika binti Zainal Abidin. My registration number is 01DKA21F1141. So let me explain three-dimensional flow. So what is a dimensional flow? It's the type of flow in which the velocity is a function of time and three mutually perpendicular directions. Let me go to picture of diagram. Example, let's say the flow in this pipeline. As we can see, starting from the back is smaller, then the longer the size is larger. The effect of the pipe change causes the water to flow with a speed in the x, y, and z direction. So it is what we call this flow is known as a three-dimensional flow.
Thank you, Atika. Okay, the three-dimensional fluid flow, the hydrodynamic parameters are function of three space coordinates and time. The next, I pass to Noor Aniza to continue this presentation.
Okay, thank you. Last but not least, in the end of the presentation, these are the codes for you guys that can use in database for your lesson in civil engineering student. There can be a little doubt that in many ways the story of civilization by it we carriedly measure an important part of people progress by frankly the resolve 1931. That's all from me. Thank you.
Hi, my name is Taufiqa and my matrix number is 01TKA 21F1001. And in this section, we have learned the difference between these three types of dimensional flow. And they are different in parameter, graph, and flowing direction. And as we know, one-dimensional flow is the flow vary in only in one direction, straight and parallel line, which is x axial direction. One-dimensional flow also affected by the parameter, such as velocity, density, pressure, and more. And all of these parameters are related to the time. And one-dimensional flow doesn't relate to time to change the parameter. So in summary, one-dimensional flow doesn't exist in real life. And then for the two and three-dimensional flow, they exist in real life, and parameter for two-dimensional flow only vary in x and y axial direction, so that it can shown in curve. And for the three-dimensional flow, it can change in three direction, and which is x, y, and z axial direction, and its streamline are shown in the space curve. And that's all from us. Thank you.